Welcome back to this presentation. Still continuing the CGS series on the angle trisection solution. This time around we'll be looking at the trisection of an angle above the third degrees configuration using the Alex method. I am as well going to use the GeoGebra software as I've demonstrated in the other videos, and this way I open it from. Well, I'm in the geometry environment in my GeoGebra. I first prepare the nested tool for use. I would also use that one and another one in here interchangeably. Here I would need to write this, and here importantly the compass. Here the geometric transformation tools one I'm going to use. Sorry. I will just create an arbitrary angle, an angle that is greater than even 90 between 2 points. That's on the points. The point is somewhere here. So I'll join the point C to point B. Okay, it's fine, I can just work it the way it is. I needed to have point A somewhere, but we'll work from point B now this time around. For the baseline, I'll use the complete straight line, that which goes to infinity. I am required to start by imposing the first condition in Alex's method to ensure that the construction will be done at the third degrees configuration. And to get that, I need to try to bisect 60. That's what I'm actually performing. I hope the tools I'm using are very clear. I'll use the angle bisector tool, bisect this angle DBC to give me 30 degrees at this point. That's fine, and I'll just give this a different color for security purposes to show that we are working at that configuration. We should not go outside that. That is it. Now, we do not have to measure the angle ABC. I just need to reduce it geometrically to a point of its submultiple angle within this configuration CE. And I'll do that by multiple bisections. However, here I must be noting the number of times I draw these bisection lines. It is still outside and very much outside the configuration CE, so I go further. Second time I divide it that way. The point is still further from outside the configuration CE, so I need to bisect it further using my tools. Perform the bisection that way, and I get the point I'm interested with, the point inside the configuration. I label that point for constructions purposes in the future of this video. So as we have done in the previous presentation, I give this a different color and pick that. That's okay. And before I forget, the other point is to construct a midpoint between B and C. That is it. I will now use this tool to map I about B into I prime and C about B into C prime. I'll use those points in the future of this presentation, and I zoom out the figure for good view. This is how I'm going to do it. Okay, let me minimize it to have everything being done from the geometry pad that way. I will now perform the trisection of the chord CH. This is the process. We use these points. That way. To perform the trisection, I've just drawn the lines, sorry, the curves without this line of interest. I just join it here. And since I'm going to construct two more lines that are parallel to this, I need to give them a different color for characteristic purpose. I label this as point J. I've got some codes here. So BJ is the segment I'm interested with, and I lift it that way to that other point using the compass tool, again that way to this other point. Having that at place, I need to zoom in the figure just lightly so that I can label here correctly. This is my point K, and I change the appearance of this for good look to a different color and pick that. Having that difficult part done, I can now zoom out the figure again so as to label this part that way, and here I give it the same color, the same property, the two curves or circles. Now I can further zoom out the figure to that. Sorry. To draw the parallel lines, I'll consider 2 points every time, B through L and I through K. Now you realize these lines, if they are parallel, then they should have the same properties, and thus I'm giving them the same color as that. I'm interested at the points of intersection between the two more lines, the two parallel lines, and the line I'm trisecting. This point, I'll label that as point M. Zoom out. I label this as point N. That way. And we're almost done, just confirmation of the result. So I need to draw a straight line through points I and N, and another straight line through point B. I can pick the other point from here because it appears hidden, M, that way. I now zoom in the figure so that I can label the points of intersection, or the points where the two lines cut the curve, CE. It's one of the points. I think I've placed it well, that's okay. And I drop the geometry pad to bring the other point my eyes, but I still need to zoom in here for accurate labeling. So I can pick the labeling tool this way. That's it. And I'm now interested in the points O and P. I'll pick points O and P. Sorry, that. Points OP. I just need to undo because I've repeated something. I do not want it to be placed there. I'll carry it and place it at point C prime. So OP, and place it here. We have sectioned this anchor how many times? Once, twice, third. So 2 power 3, that is 8. And I have to stroke this new segment along this curve 8 times for me to get the trisection of this anchor and examination. I zoom out slightly now. I can confidently draw the points. Carry that. I need to do this 8 times. So at that point I have 2, and I can easily get 4. Just pick this huge one that way. I can get that. That's 4, and I can get 8 with such ease. I can zoom out to give me the 8th one, and I label this point as point T. So I changed the appearance of that to show it's carrying some important property into maybe that reddish, that way. If we measure the size of this angle, it should be a third of the angle ABC. Its size is 44.17. The size of ABC, the angle ABC is 227. Now that is the exterior side, and in the scale of 180, it is 132.51. We can check 44.17 multiplied by 3 from the calculator gives 132.51 exactly. So that's how we can perform the trisection of angles above the 3rd degree scale or configurations using the Alex's method. That's how it looks like when you stretch to 15 decimal places. But so it's fine in terms of for conventionality and applicability, it's okay. So up to 3 decimal places, the solution is okay. So that is it. That's all in short with the trisection of an angle above the 3rd degrees configuration. You can minimize this, delete that. I go back into my slides, and that marks the end of the presentation.